In this video lecture, we are going to see one topic, probabilistic generative models from the third unit of artificial intelligence and machine learning. Objectives are to understand about the conditional probability and joint probability and to apply Bayes theorem. Probabilistic generative models are class of statistical models that generate new data instances. These models are used in unsupervised machine learning to perform tasks such as probability and likelihood estimation, modeling data points, and distinguishing between classes using these probabilities. It uses the Bayes theorem to find the joint probability, and it describes how data is generated using probabilistic models. They predict probability of y on x, the probability of y given x, calculating the p of x comma y, the probability of x and y. Naive Bayes classifiers. Naive Bayes classifiers are a family of probabilistic classifiers which performs with the help of Bayes theorem with strong independence assumption between the features. It is highly scalable and it requires a number of parameters linear in the number of variables in a learning problem, which Naive Bayes classifier predicts the class value when given a set of attributes. For each known class value, it will calculate the probabilities of each attribute conditional on the class value, which will use the product rule to obtain the joint conditional probability for the attributes and use the Bayes rule to derive conditional probabilities for the class variable. Once this has been done for all the values, output the class with the highest probability. It simplifies the calculation of probabilities by assuming that the probability of each attribute belonging to a given class value is independent of all the attributes. The conditional probability, by multiplying the conditional probabilities together for each attribute for a given class value, we have a probability of a data instance belonging to that class. So let us take two events A and B, and both are related events. The probability of conditional probability of B on A can be calculated by the ratio of P of A and B and P of A. Similarly, conditional probability of an even A given by B, P of A on B is equal to P of A and B divided by P of B. So the conditional probability is defined quantity and cannot be proven. Joint probability. A joint probability is a probability that measures the likelihood that two or more events will happen concurrently. If there are two independent events A and B, the probability that A and B will occur is found by multiplying the two probabilities. Thus, for two events A and B, the special rule of implication shown symbolically is P of A and B is equal to P of A into P of B. So by applying the probability formulas, we can derive many formulas like this. All these formulas are used for probabilistic generative models. And already we have studied about the Bayes theorem. Bayes theorem is a method used to revise the probability of an event given the additional information. And in the Bayes theorem uses the conditional probability values. It gives the relation between P of A on B and P of B on A. And it gives the rule how to update or revise the strength of evidence-based belief in light of new evidence posterior. A prior probability is an initial probability value originally obtained before any additional information is obtained. But a posterior probability is a probability value that has been revised by using some additional information that is later obtained. In this way, when we consider the sequence of events like B1, B2, B3, etc. up to Bk, we can also derive the formula to find out the conditional probability of the set of events B by considering its related event A, that is P of Bk on A. And there are some differences also there between the generative models and discriminative models. Generative models generate new data instances, but discriminate model discriminate between the different kinds of data instances. Thank you.